Welcome back to G Fun Facts Online. Today we are diving deep into one of the most radical shifts in our understanding of human biology in the last century. We are talking about the brain's hidden plumbing system. For over 200 years, medical textbooks described the human brain as a biological fortress. It was called immune privileged, a fancy way of saying it was a sovereign island, completely cut off from the body's immune system. The dogma was that while every other organ in your body, your liver, your heart, your skin, had a network of lymphatic vessels to clear out waste and transport immune cells, the brain did not. We believed the brain was simply too special, too delicate to have these sewer pipes running through it. We thought it passively dumped its trash into the cerebrospinal fluid or recycled it internally. It turns out we were completely wrong. That dogma has not just cracked, it has collapsed. Between 2015 and 2026, neuroscientists mapped a hidden network of vessels that had been staring us in the face for centuries, invisible only because we didn't know how to look. These are the meningeal lymphatic vessels, and they are the missing link between your brain and your immune system. Today, we are going to explore the anatomy of this invisible network, the molecular machinery that keeps it running, and the devastating consequences when it clogs up, leading to diseases like Alzheimer's and Parkinson's. We will also cover the cutting-edge diagnostics and the futuristic therapies that aim to unclog our brains. Let's start with the anatomy of the invisible. The lymphatic system is essentially the body's sewer and security network. It drains excess fluid and waste from tissues and moves immune cells to lymph nodes. For centuries, anatomists dissected brains and saw nothing but nerve tissue and blood vessels. The lymphatic vessels were there, tucked away in the dura mater, the tough outermost layer of the protective membranes covering the brain, but they were collapsed and translucent, making them effectively invisible to the naked eye. The breakthrough happened when researchers finally used advanced microscopy on hole-mounted mouse meninges. Suddenly, they saw distinct vessels running parallel to the large veins that drain blood from the brain. These vessels lit up with classic lymphatic markers like PROX1, LYVE1, and podoplanin. Unlike the chaotic web of capillaries in your skin, the brain's lymphatic architecture is highly organized. We now know it consists of two distinct functional zones. First, you have the dorsal network. These vessels run along the very top of the brain, following the superior sagittal sinus. Think of these as the roof drains of a house. They capture cerebrospinal fluid and immune cells from the upper hemispheres and funnel them toward the back of the skull. For a few years after the initial discovery, we thought this was the main route. But around 2025 and 2026, a major leap forward occurred. Researchers identified the ventral network, specifically the MMA pathway. This runs along the base of the brain, following the middle meningeal artery. While the dorsal vessels are like narrow gutters, these ventral vessels are wider and have a complex branch-like structure. This area is the heavy-duty industrial drain of the brain. Recent MRI studies using contrast agents in humans have shown that this pathway handles a massive volume of fluid and waste clearance, with flow dynamics perfectly matching the slow, passive profile of lymphatic drainage. Now, to understand how the brain actually cleans itself, you have to understand the relationship between the drain and the sink. This brings us to the connection between the glymphatic system and these meningeal lymphatic vessels. The glymphatic system is a plumbing system inside the brain tissue itself. It relies on glial cells, specifically astrocytes. These astrocytes wrap their end feet around blood vessels, creating a tunnel called the perivascular space. Cerebrospinal fluid is pumped into the brain through these tunnels, driven by the pulsing of your arteries. This fluid washes through the brain tissue, sweeping up metabolic waste like amyloid beta and tau proteins, and pushes them toward the veins. This is where the handshake happens. The glymphatic system pushes this waste-laden fluid out of the deep brain tissue and into the subarachnoid space, the area between the brain and the skull. Once there, the fluid is taken up by the meningeal lymphatic vessels in the dura mater. Think of it this way. The glymphatic system is like the janitorial staff, sweeping the hallways and dumping the trash into the bins outside the building. The Meningeal lymphatics are the garbage trucks that come to the curb, pick up the trash and haul it away to the dump, which in this case are the lymph nodes in your neck. If either system fails, the trash piles up. Let's look at the molecular machinery that powers this system, because this is where the key to future therapy lies. The superstar molecule here is vascular endothelial growth factor C, or VEEGFC. This protein is the signal that tells the body to grow new lymphatic vessels. It binds to a receptor called VEGFR3 on the surface of lymphatic cells. In young, healthy brains, there is an abundance of VEGF-C, keeping the vessels lush, wide, and leak-proof. But as we age, VEGF-C levels drop. The vessels begin to wither, becoming thinner and sparser. This lymphatic regression is a primary driver of brain aging. Then there are the architects, proteins like PROX1 and FOXC2. PROX1 maintains the identity of these cells. Without it, they forget they are lymphatic cells and stop working. FOXC2 is crucial for forming valves. Just like veins in your legs, These vessels need one-way valves to prevent fluid from flowing backward. Research shows that without FOXC2, the vessels become leaky pipes, allowing toxic waste to seep back toward the brain. The cells lining these vessels are connected by specialized zipper junctions. When fluid pressure rises, like during deep sleep, these zippers open up to let waste in, then close to seal the vessel so it can be pumped away. In neurodegenerative diseases, these zippers often fail, either becoming permanently sealed or permanently open. This brings us to the critical role of sleep. We have known for a while that sleep cleans the brain, but the details have recently become much clearer. During sleep, the space between brain cells actually expands by up to 60%. This reduces resistance, allowing the lymphatic fluid to wash through the tissue much faster. Simultaneously, the meningeal lymphatic vessels ramp up their activity. For years, we believed this only happened during deep, slow-wave sleep, but 2025 research using wearable electrical impedance spectroscopy has upended this view. Scientists can now measure the resistance of brain tissue to safe electrical currents in real time. They found that waste clearance is a dynamic cycle active during both deep sleep and REM sleep. Crucially, the efficiency of the system accelerates the longer you sleep. The rinse cycle is most powerful in the late hours of the night, the early morning hours, which are typically rich in REM sleep. Cutting sleep short aborts this heavy-duty cleaning phase. The development of wearable glymphometers means we can now measure this flow without an MRI, offering a potential early warning system for Alzheimer's years before memory loss begins. Speaking of Alzheimer's, let's talk about what happens when the drain clogs. The failure of meningeal lymphatic drainage is now recognized as a universal aggravator of neurodegenerative disease. In Alzheimer's, we see the accumulation of amyloid beta plaques and tau tangles. For decades, we asked why the brain was making too much amyloid. Now we ask, why isn't the brain clearing it? In mouse models, destroying these lymphatic vessels causes amyloid plaques to accumulate instantly. Conversely, boosting them with VEGF-C reduces plaque load. The gene ApoE4, the strongest genetic risk factor for Alzheimer's, appears to directly harm these vessels, making them brittle and less responsive. In Parkinson's disease, the protein alpha-synuclein clumps together. The meningeal lymphatics are the primary exit route for this protein. When blocked, it backs up, causing inflammation and neuronal death. We also see senescent astrocytes, or zombie cells, which stop dividing and pump out toxins. Normally, the immune system clears these via the lymphatics, but when the vessels degrade, these zombie cells are trapped, creating a feedback loop of inflammation. Even traumatic brain injury plays a role. A hit to the head can tear these delicate vessels, creating a permanent scar in the drainage system that leads to dementia decades later. So how do we diagnose this? If the brain dumps its trash into the lymph nodes, looking at the trash can should tell us what is happening in the kitchen. The meningeal lymphatics drain directly into the deep cervical lymph nodes in the neck. In 2024, a team at Oxford University proved that aspirating fluid from these neck nodes offers a super-concentrated view of brain health. They found levels of PTAU181, a key Alzheimer's marker, were over 200 times higher in the lymph nodes than in the blood. This needle in a neck node technique could revolutionize diagnosis, allowing doctors to read the brain's waste output directly. Finally, let's look at the therapeutic frontiers. The most direct approach is VEGF-C gene therapy. Injecting a viral vector that codes for VEGF-C into the fluid reservoir at the base of the skull causes old vessels to sprout and regrow. In mice, this improved flow and memory. Biotech companies are working to translate this to humans. There are also drainage drugs being developed to activate the PROX1 pathway, and even photobiomodulation, using near-infrared light to stimulate the mitochondria in lymphatic cells. While we wait for these therapies, there are things you can do right now. The deep cervical lymph nodes in the neck are the bottleneck of the system. Physical movements like shoulder shrugs and rolls can compress and release the tissues around these nodes, creating a suction effect. Diaphragmatic breathing helps too, as the body's main lymph drain passes through the diaphragm, and deep belly breathing creates a vacuum that sucks fluid toward the heart. Sleep position matters as well. Animal studies suggest that sleeping on your side is the most efficient posture for lymphatic clearance. And of course, diet plays a role. Insulin resistance hardens arteries and damages these vessels, while intermittent fasting may boost the autophagy and flushing phases of the cycle. In conclusion, the discovery of meningeal lymphatic vessels is one of the most significant anatomical updates of the 21st century. It turns brain health into a fluid dynamics problem. We no longer view the brain as a static fortress, but as a dynamic city with a complex waste management infrastructure. We now know that this infrastructure collapses with age, leading to the pollution we call dementia. But for the first time, we have the blueprints to fix the pipes. From the middle meningeal artery to the lymph nodes in our neck, we are mapping the routes that keep our minds clear. The future of treating Alzheimer's may not just be about clearing plaques, but about fixing the plumbing so the brain can clean itself. Thanks for listening to G Fun Facts Online.